So hello everyone, today we'll be solving this question. So this question too is kind of related to changing it into partial fractions, but then it's not about comparing coefficients or something like that. So let's just see how it is done. So when you have, let's say x minus 1 whole square, x minus 2 whole cube, when you have things like that and nothing in the numerator, then what you can do is you can let one of the terms here, let's assume x minus 1 is equal to another variable for now, x minus 2. So we are supposing this to be one condition, and from here we are going to find the value of x. So let's multiply this with this and then this with this, and then what we will get is x minus 1 is equal to zx minus 2z. And again, let's bring this over here so that we can take x common. So if we take x common, then this is equal to 1 minus 2z. Therefore, x is equal to 1 minus 2z over 1 minus z. So after this, what we will do is differentiate this entire term with respect to z. So not x right now, but then z. So dx dz is equal to, we are going to use the quotient rule over here. So I don't think that needs to be done, and so this is what you will get even if you apply the rule. So this multiplied by, I think, minus 1 over, of course, 1 minus z whole square. So after this, let's send this dz over there, and then let's multiply things over here and here. So if you do that, the value of dx that you will get will be minus 1 over 1 minus z whole square times dz, of course. So now let's look into the question once again. So this is the question. We have a new value for dx, we have a new value for x as well from here. So what you can do is change the original question into the forms where we use the new value. So is equal to the integration sign. The value of dx would be the one we found out just now, and then whole divided by, again, let's express x minus 1 into the value containing z. So it is z. Yes, and I'm sorry if the noise of the dog barking is disturbing you. Yep. So this is the reformed question, I would say. So now what you can do is you can, since the bases are same over here, you can add the power. So it would be x minus 2 to the power 5. And yes, so let's do that. Minus 1 minus z whole square dz whole divided by z square times z minus 2 to the power 5. So after this, what we can do is the value of z was something that we supposed here, so z is not something given in the question. So now let's replace z with x. So if you send this term to the left hand side, then you'll find the value of z. So let's do that in other page. So if you are to do that, what you will get is, first of all, I think let's replace the value of x, and because we have z over here, so it's best to change the value of x, then later on finally change the value of z as well. So what you will have is minus 1. I've changed the color of the pen so that becomes not so monotonous. So 1 minus 2z over 1 minus z minus 2 to the power 5, isn't it? So now if you are to take LCM, if you are to send the terms over here upwards, then what you will find is 1 minus z to the power 5 over z square by 1 minus z whole square dz. So now this and this are similar, so power can move upwards. What you will get is 1 minus z to the power whole cube by z square dz. So in this step all you have to do is take LCM and you will get this step, and then you will move whatever is over here upwards and you get this one. It's not very difficult. Let's move to this page. And if you are to open this thing in the form of a minus b whole cube, then what you will find is 1 minus 3z plus 3z square minus z cube. All I've done here is open it in the form of formula z square, of course, dz. So now it's simple integration. You're just going to divide them, like you're going to separate. Separate. I think this was not needed. Yep, now it's fine. So you're just going to separate them into different integrals, and if you do that, then what you will find, the answer is 1 minus z minus 3 ln z plus 3z minus z square upon z plus c. So first I found the integration of 1 over z square, and then again 3z over z square. That would be 3 integration 1 over z, and so on. So that's what I've done here. So now let's change the value of z in the form of x. So if you are to do that, you would find the answer as, I'm going to present it in a raw form. I don't think you need to go through expanding them, then again simplifying them, and so on. That's not needed. So just simply replace the value of z with the value of x. So it is, of course, x over 2 minus, what would it be? Yep, I think this is whole divided by whole square plus c. So there you go. This is the final answer to this question. It's a little difficult, a little bit different from the questions that we normally attempt, but then all you have to do is suppose one term in the form of another, and then the rest just gets easier. So I hope you learned how to do this, and hope to see you in my next videos. Thank you.